10 powerful functions of optocoupler. Optocouplers, also known as opto-isolators or optical isolators, are devices that use light waves to transfer electrical signals between isolated sections of a circuit. They are commonly used in electronic systems for various purposes. Here are 10 powerful functions of optocouplers. Number 1 is electrical isolation, refers to the separation of different sections of a circuit to prevent the flow of electric current between them. This isolation is achieved using various techniques and components, and optocouplers are a common solution for providing electrical isolation in electronic systems. Here's a more detailed explanation of electrical isolation. Preventing ground loops. Electrical isolation helps to prevent ground loops, which can occur when there are multiple paths for current to flow between different sections of a system. Ground loops can introduce unwanted noise and interference into the circuit. Safety and protection. Isolation is essential for safety reasons, especially when dealing with high voltages. It helps protect sensitive components and low-voltage sections of a circuit from potential damage caused by voltage spikes or faults in other parts of the system. Galvanic isolation. Optocouplers provide galvanic isolation, meaning there is no direct metallic connection between the input and output sides. Instead, they use light waves to transmit signals, ensuring that there is no direct electrical connection between the two sections. High voltage and low voltage separation. In many applications, there is a need to separate high voltage and low voltage sections of a circuit. This is common in power supplies, motor control systems, and industrial applications. Optocouplers allow for communication between these sections without a direct electrical link. Interference mitigation. Electrical isolation helps mitigate interference and noise that can be induced by high voltage or high current components. By preventing the direct transfer of electrical signals, the impact of noise on sensitive circuitry is reduced. Data integrity. In communication systems, especially those involving long-distance transmission or harsh environments, electrical isolation is crucial for maintaining data integrity. It prevents issues such as signal distortion or corruption caused by ground differentials or electromagnetic interference. Compliance with safety standards. Many electronic systems, especially those used in medical devices, automotive applications, or industrial environments, must comply with safety standards. Electrical isolation is often a requirement to meet these standards and ensure user safety. Control system protection. In control systems, such as those found in industrial automation, electrical isolation is used to protect the control electronics from the high-power components they are controlling. This separation helps prevent damage to the control system in the event of a fault or malfunction in the power circuit. In summary, electrical isolation is a critical aspect of electronic design, providing protection, safety, and reliable operation in various applications. Optocouplers play a key role in achieving electrical isolation by using light signals to transmit information across isolated sections of a circuit. Number 2 is signal transmission, refers to the process of conveying information from one point to another within an electronic system. This communication can involve various types of signals, including digital or analog, and it's essential for the proper functioning of electronic devices and systems. Optocouplers are often used for signal transmission, and here's how they contribute to this process. Isolated signal transfer. Optocouplers use light waves to transfer signals, ensuring electrical isolation between the input and output sides. This is particularly important when transmitting signals between components with different ground potentials or in the presence of high voltages. Digital signal transmission. Optocouplers can transmit digital signals efficiently. In digital communication, they convert electrical signals on the input side into light pulses, which are then detected on the output side and converted back into electrical signals. This is common in applications like microcontroller interfacing and data communication. Pulse transmission. Optocouplers are capable of transmitting pulses of light to represent digital information. This is widely used in applications where data integrity is crucial, such as in communication interfaces like RS-232, RS-485, or USB. Analog signal transmission. While optocouplers are often associated with digital signals, they can also be used for analog signal transmission. This is important in applications where maintaining the integrity of the analog signal is essential, such as in audio systems or sensor interfaces. High-speed communication. Some optocouplers are designed to operate at high speeds, enabling the transmission of signals with fast rise and fall times. This makes them suitable for high-frequency applications, such as in telecommunications or high-speed data links. Protection from electromagnetic interference. Optocouplers provide a level of immunity to electromagnetic interference, EMI, since the light signal is less susceptible to external electromagnetic fields. This makes them suitable for applications where signal quality is critical and interference must be minimized. Microcontroller and peripheral communication. Optocouplers are often used to facilitate communication between microcontrollers and peripherals such as relays, motors, or other high-power devices. This allows the microcontroller to control external components while remaining electrically isolated. Power supply feedback. In power supply circuits, optocouplers can be used to transmit feedback signals from the output to the input, enabling precise control and regulation of the power supply voltage. This is common in switched-mode power supplies. In summary, optocouplers play a crucial role in signal transmission by providing electrical isolation and enabling the transfer of information between different sections of a circuit. Their versatility makes them valuable in a wide range of applications where signal integrity, safety, and noise immunity are important considerations. Number 3 is voltage level shifting involves changing the voltage level of a signal from one voltage range to another. This is often necessary in electronic circuits where different components or sections operate at distinct voltage levels. Optocouplers can be employed to perform voltage level shifting, and here's how. Isolation between voltage levels. Optocouplers provide electrical isolation between the input and output sides. This isolation is crucial when shifting voltage levels to prevent direct electrical connections between sections operating at different voltage potentials. High to low level shifting. In scenarios where a signal needs to be shifted from a higher voltage level to a lower one, optocouplers can be used to achieve this transition. The signal is modulated onto a light signal on the high voltage side, transmitted optically, and then demodulated to the lower voltage level on the output side. Low to high level shifting. Similarly, optocouplers can shift signals from a lower voltage level to a higher one. This is accomplished by modulating the signal onto a light signal at the lower voltage input side, transmitting it optically, and then demodulating it to the higher voltage level on the output side. Interface compatibility. Optocouplers can be used to interface components with different voltage requirements. For example, when connecting a low-voltage microcontroller to a high-voltage device, an optocoupler can act as an interface to shift the voltage levels and provide isolation. Logic level translation. In digital systems where different components operate at distinct logic voltage levels, e.g., 3.3V and 5V, optocouplers can be used to translate logic signals between these levels, ensuring proper communication and compatibility. Sensor interfaces. Optocouplers are often employed in sensor interfaces, especially when sensors operate at different voltage levels than the processing electronics. This is common in industrial applications where sensors may generate signals at higher voltages. Mixed voltage systems. In mixed voltage systems, where different sections of the circuit operate at different voltage levels, optocouplers can facilitate communication between these sections while providing the necessary isolation. Protection of low-voltage components. Optocouplers can be used to protect low-voltage components from potential damage caused by high-voltage spikes or faults in other parts of the circuit. The optical isolation prevents the transmission of damaging voltages. In summary, optocouplers are valuable in voltage-level shifting applications due to their ability to provide electrical isolation and transmit signals optically. This ensures compatibility and protection between components operating at different voltage levels in electronic circuits. Number 4 is optocouplers play a significant role in data communication by providing a means of transmitting signals between isolated sections of a circuit. Here's how optocouplers contribute to data communication. Electrical isolation. One of the primary functions of optocouplers in data communication is to provide electrical isolation between the input and output sides of the circuit. This isolation helps prevent ground loops, reduces the risk of damage to components, and enhances the overall safety of the system. Digital signal transmission. Optocouplers are commonly used to transmit digital signals across isolated sections of a circuit. In digital communication, they convert electrical signals into light pulses on the input side, transmit these pulses across the isolation barrier, and then convert them back into electrical signals on the output side. Noise immunity. The optical transmission in optocouplers provides inherent immunity to electromagnetic interference (EMI) and helps reduce the impact of noise on the transmitted signals. This is particularly important in environments where noise can degrade the quality of the data. Serial communication interfaces. Optocouplers are used in serial communication interfaces such as RS-232, RS-485, and UART. They enable communication between devices at different ground potentials or in the presence of high voltages, ensuring reliable data transmission. Microcontroller interfacing. Optocouplers facilitate communication between microcontrollers and other components in a system. They allow microcontrollers to control or receive data from devices like sensors, relays, or other high-power components while maintaining electrical isolation. Fiber optic communication. Some optocouplers are designed to interface with fiber optic cables, enabling data transmission over longer distances and providing additional benefits such as increased bandwidth and immunity to electromagnetic interference. Data integrity in harsh environments. In industrial or automotive applications where the environment may be harsh, optocouplers help maintain data integrity by preventing interference and protecting sensitive electronic components from external factors. Isolated interfaces in medical devices. Optocouplers are commonly used in medical devices where electrical isolation is critical. They provide a safe means of transmitting data between different sections of a medical device, ensuring patient safety and compliance with regulatory standards. Feedback systems. In feedback systems, optocouplers can be employed to transmit information from the output to the input, allowing for closed-loop control. This is often used in applications such as power supplies, where feedback is essential for regulation. Ensuring system reliability. By isolating communication paths, optocouplers contribute to the reliability of data communication systems. They protect sensitive electronics from potential damage and improve the overall robustness of the system. In summary, optocouplers are versatile components that play a crucial role in data communication, offering electrical isolation, noise immunity, and the ability to transmit signals reliably across isolated sections of a circuit. Number 5 is optocouplers are commonly used in switching power supplies to provide feedback and electrical isolation. Here's how they contribute to the functionality of switching power supplies. Feedback loop isolation. Optocouplers are often used in the feedback loop of switching power supplies. They provide electrical isolation between the output voltage and the control circuitry, preventing direct electrical connections that could lead to ground loops or voltage spikes. Voltage regulation. The feedback loop in a switching power supply monitors the output voltage and adjusts the switching action to maintain a stable and regulated output. Optocouplers help transmit the feedback signal across the isolation barrier, allowing precise control of the power supply output voltage. Isolation from high voltage. In high-voltage power supplies, such as those used in industrial or power distribution applications, optocouplers ensure that the control circuitry is isolated from the high-voltage sections. This protects the low-voltage control components from potential damage. Enhanced safety. The electrical isolation provided by optocouplers enhances the safety of switching power supplies. It reduces the risk of electric shock, protects against voltage transients, and helps the power supply meet safety standards and regulations. Fault protection. Optocouplers contribute to fault protection by preventing faults in the high voltage section from affecting the low voltage control circuitry. This is crucial for maintaining the integrity of the power supply and preventing catastrophic failures. Improved noise immunity. Switching power supplies can generate electrical noise during operation. The use of optocouplers helps improve the noise immunity of the control circuitry by preventing the direct transfer of noise from the high voltage section to the low voltage section. Current sensing and limiting. Optocouplers can be employed in current sensing circuits to monitor the output current of the power supply. This information is used to implement current limiting and protection features, ensuring that the power supply operates within safe limits. Feedback signal transmission. The optocoupler transmits the feedback signal from the output to the control circuitry optically. This is typically achieved by modulating the light emitted by an LED on the input side, and then detecting and demodulating the light on the output side to generate the feedback signal. Galvanic isolation. The galvanic isolation provided by optocouplers helps prevent ground loops and isolates the control circuitry from the high voltage components. This is essential for maintaining signal integrity and preventing interference. Wide input voltage range. Optocouplers allow switching power supplies to accommodate a wide range of input voltages while providing a controlled and stable output voltage. This is important for power supplies used in various applications with different input voltage requirements. In summary, optocouplers play a crucial role in switching power supplies by providing electrical isolation, facilitating feedback for voltage regulation, ensuring safety, and protecting the control circuitry from the high voltage components. Number 6 is optocouplers are commonly used in microcontroller interfaces to provide electrical isolation between the microcontroller and other components or systems. Here's how they contribute to microcontroller interfacing. Isolation from high voltage components. Optocouplers ensure that the microcontroller is electrically isolated from high voltage or high current components, such as relays, motors, or power circuits. This protects the sensitive microcontroller from potential damage caused by voltage spikes or noise. Protection against ground loops. Electrical isolation helps prevent the formation of ground loops, which can introduce unwanted noise and affect the accuracy and reliability of signals. Optocouplers break the electrical connection between different ground potentials. Reliable signal transmission. Optocouplers use light signals to transmit information, ensuring a reliable and noise-resistant communication path between the microcontroller and external components. This is especially important in industrial environments or applications with high levels of electrical noise. Bidirectional communication. Some optocouplers support bidirectional communication, allowing data to be transmitted in both directions between the microcontroller and external components. This flexibility is beneficial in systems where two-way communication is required. Switching applications. In applications where the microcontroller needs to control high-power devices, such as switches or relays, optocouplers act as a barrier, allowing the microcontroller to send control signals without being directly connected to the high-voltage components. Motor control. Optocouplers are often used in motor control systems where a microcontroller is responsible for driving and controlling motors. The isolation provided by optocouplers protects the microcontroller from back EMF and other electrical disturbances associated with motor operation. Feedback systems. In systems that require feedback for control purposes, optocouplers can be used to transmit feedback signals from sensors or monitoring devices back to the microcontroller. This allows the microcontroller to adjust its output based on the feedback received. UART and serial communication. Optocouplers are employed in serial communication interfaces, such as UART, to allow the microcontroller to communicate with other devices without direct electrical connections. This is particularly useful when interfacing with devices that operate at different voltage levels. Ensuring system safety. By isolating the microcontroller from high-voltage or potentially hazardous components, optocouplers contribute to the safety and reliability of the overall system. This is critical in applications where user safety is a priority. Compliance with standards. Optocouplers are often used to meet safety and regulatory standards in applications where electrical isolation is required. This is common in medical devices, industrial automation, and other safety-critical systems. In summary, optocouplers are valuable components in microcontroller interfaces, providing electrical isolation, noise immunity, and protection against potential hazards. They enhance the reliability and safety of systems where microcontrollers need to communicate with external components or operate in environments with different electrical potentials. Number 7 is optocouplers are often used in applications involving analog signals to provide electrical isolation and maintain signal integrity between different sections of a circuit. Here's how optocouplers contribute to analog signal isolation. Electrical isolation. Optocouplers use light signals to transmit analog information, ensuring complete electrical isolation between the input and output sides of the circuit. This isolation helps prevent ground loops and minimizes the risk of damage to sensitive components. Signal integrity preservation. Analog signals can be susceptible to noise and interference. Optocouplers help preserve the integrity of analog signals by isolating them from potential sources of interference, such as high-voltage circuits or noisy environments. High common mode rejection. Optocouplers often have high common mode rejection ratios, CMRR, meaning they can reject common mode noise present on both the input and output sides. This feature enhances their effectiveness in preserving the fidelity of analog signals. Data acquisition systems. In data acquisition systems where accurate measurement of analog signals is crucial, optocouplers provide a means of isolating measurement circuitry from the rest of the system. This isolation helps maintain the accuracy of the acquired data. Instrumentation amplifier interfaces. Optocouplers are used in interfaces between instrumentation amplifiers and external sensors or transducers. They ensure that the analog signals from the sensors are transmitted with high fidelity to the instrumentation amplifier while keeping the amplifier isolated. Control systems and sensors. In control systems where analog signals from sensors need to be transmitted to a controller or vice versa, optocouplers facilitate the isolation of these signals. This is common in industrial automation and process control applications. Audio signal transmission. Optocouplers can be utilized in audio systems to transmit analog audio signals across isolated sections of a circuit. This helps prevent interference and ground loops that can degrade the quality of the audio signal. Isolation in power electronics. In power electronics applications, such as isolated power supplies or inverters, optocouplers can be used to transmit analog feedback signals for control purposes while maintaining electrical isolation. Signal conditioning. Optocouplers are employed in signal conditioning circuits where analog signals need to be conditioned or processed before being sent to the receiving circuit. The isolation provided by optocouplers protects sensitive components during the conditioning process. Measurement and test equipment. Optocouplers play a role in measurement and test equipment, ensuring that analog signals from devices under test are accurately and safely transmitted to measurement instruments, even in the presence of high-voltage or noisy environments. In summary, optocouplers are valuable components for analog signal isolation, offering electrical isolation, noise immunity, and signal integrity preservation. They find applications in various fields where accurate transmission of analog signals is crucial for the proper operation of electronic systems. Number 8 is optocouplers are commonly used in motor drive systems to provide electrical isolation between the low-voltage control circuitry, typically governed by a microcontroller or control system, and the high-voltage components associated with the motor. Here's how optocouplers contribute to motor drive isolation. Isolation for safety. Motor drive systems often involve high-voltage and high-current components. Optocouplers ensure electrical isolation between the low-voltage control section and the high-voltage power section, enhancing the safety of the overall system. Prevention of ground loops. Optocouplers help prevent ground loops by breaking direct electrical connections between different ground potentials in the control and power sections. Ground loops can introduce unwanted noise and affect the performance of the motor drive system. Control signal transmission. Optocouplers transmit control signals such as PWM, pulse width modulation, signals from the low-voltage control circuitry to the high-voltage power section. This allows the microcontroller to regulate the motor's speed and direction without direct electrical connections. Feedback signal transmission. In motor control systems, feedback signals from sensors or encoders, such as speed or position feedback, are crucial for closed-loop control. Optocouplers facilitate the transmission of these feedback signals back to the low-voltage control circuitry, enabling precise control of the motor. Protection of control electronics. Electrical isolation provided by optocouplers safeguards the low-voltage control electronics from potential damage caused by voltage spikes, motor-induced noise, or other electrical disturbances associated with high-power motor operation. Reducing electromagnetic interference, EMI. Motors can generate electromagnetic interference during operation. Optocouplers contribute to reducing the impact of EMI on the control circuitry by providing a barrier against direct electrical connections. Bidirectional communication. Some motor drive systems require bidirectional communication between the low-voltage control circuitry and the high-voltage power components. Optocouplers can support bidirectional data transmission, ensuring flexibility in system design. Variable frequency drives, VFDs. In VFDs, which control the speed of AC motors by varying the frequency of the supplied power, optocouplers are employed to isolate the control signals in feedback loops. This isolation ensures accurate and safe control of the motor speed. Industrial automation. Optocouplers are widely used in industrial automation systems where precise control of motors is essential. They help maintain signal integrity and protect sensitive control electronics in harsh industrial environments. Compliance with safety standards. Motor drive systems, especially those used in medical devices, automotive applications, or industrial equipment, must often comply with safety standards. Optocouplers play a role in meeting these standards by providing necessary electrical isolation. In summary, optocouplers play a critical role in motor drive systems by ensuring electrical isolation, preventing ground loops, facilitating the transmission of control and feedback signals, and protecting sensitive control electronics from the challenges associated with high-power motor operation. Number 9 is optocouplers are used in instrumentation and measurement systems to provide electrical isolation, improve accuracy, and enhance safety. Here's how optocouplers contribute to these applications. Electrical isolation. Optocouplers offer galvanic isolation, separating the input and output sides of the circuit. In instrumentation and measurement systems, this isolation helps prevent ground loops and minimizes the risk of damage to sensitive components. Sensor signal conditioning. Optocouplers can be used in sensor interfaces to condition and transmit signals from sensors to measurement circuits. This is particularly useful in applications where the sensors operate at different voltage levels or in environments with high electrical noise. Data acquisition systems. In data acquisition systems, optocouplers provide isolation between the analog or digital input signals and the measurement and control circuits. This isolation helps maintain signal integrity and protects the measurement equipment from potential electrical disturbances. Precision measurements. Optocouplers contribute to precision measurements by isolating measurement circuits from power fluctuations, ground potential differences, and other external influences that could affect the accuracy of the measurements. Voltage and current measurement. Optocouplers are employed in voltage and current measurement applications, ensuring that the measurement circuits are isolated from the high voltage or high current components being measured. This isolation enhances safety and accuracy. Signal conditioning and amplification. Optocouplers can be used in signal conditioning and amplification circuits to transmit conditioned signals across isolated sections of a circuit. This is important for maintaining the quality of the signal in measurement applications. Remote sensing. In situations where sensors are remotely located from the measurement equipment, optocouplers enable the transmission of sensor signals over long distances while maintaining electrical isolation. This is common in industrial and automation settings. Control system interfaces. Optocouplers are used to interface measurement and control systems in applications where the control circuitry needs to be isolated from the measurement circuits. This is crucial for maintaining the integrity of both the control and measurement systems. Calibration and test equipment. Optocouplers play a role in calibration and test equipment by ensuring accurate transmission of signals during the calibration process. The isolation they provide helps prevent interference that could impact calibration accuracy. Medical instrumentation. In medical devices and instrumentation, where safety is paramount, optocouplers are employed to provide isolation between measurement circuits and control systems, reducing the risk of electric shock and ensuring compliance with medical safety standards. In summary, optocouplers are valuable components in instrumentation and measurement systems, offering electrical isolation, signal integrity, and protection against external influences. Their use contributes to the accuracy, safety, and reliability of measurements in a variety of applications. Number 10 is optocouplers can be employed in audio systems for the transmission of audio signals, providing electrical isolation and minimizing the risk of interference. Here's how optocouplers contribute to audio signal transmission. Electrical isolation. Optocouplers offer electrical isolation between the input and output sides of the circuit. In audio systems, this isolation helps prevent ground loops and minimizes the potential for noise and interference between different components. Interfacing with different ground potentials. In situations where audio components have different ground potentials, optocouplers facilitate the transmission of audio signals without direct electrical connections, reducing the risk of noise and hum. Signal integrity preservation. The use of optocouplers helps preserve the integrity of audio signals by isolating them from potential sources of electrical noise or interference, such as high-voltage circuits or other equipment in the system. Prevention of ground loop hum. Ground loops can introduce unwanted hum into audio systems. Optocouplers break the direct electrical connection between different ground potentials, helping to eliminate ground loop issues and improving audio signal quality. Audio signal level shifting. Optocouplers can be used for level shifting in audio applications where different voltage levels need to be accommodated. This is particularly useful when interfacing audio components with varying signal levels. Audio equipment interfacing. Optocouplers provide a means of interfacing audio equipment, such as amplifiers, mixers, or equalizers, with other components in the system while maintaining electrical isolation. This is crucial for minimizing the impact of electrical noise. Speaker protection circuits. In speaker protection circuits, where control signals are sent to protect speakers from overloading or faults, optocouplers can be used to isolate the control circuitry from the high-power audio amplifier, ensuring reliable and safe operation. Audio signal feedback. In audio systems that utilize feedback for control purposes, optocouplers can be employed to transmit feedback signals from the output to the input while maintaining electrical isolation. This is common in applications like audio amplifiers. Preventing EMI. Audio systems can be susceptible to electromagnetic interference, EMI. Optocouplers, by providing optical isolation, help reduce the impact of EMI on the audio signals, leading to cleaner and more reliable audio transmission. Home entertainment systems. In home entertainment systems where various audio components are interconnected, optocouplers can be used to isolate different sections of the system, ensuring clear audio transmission and minimizing the risk of interference. In summary, optocouplers contribute to audio signal transmission by providing electrical isolation, preserving signal integrity, and preventing common issues such as ground loops and interference. Their use enhances the performance and reliability of audio systems, particularly in applications where high-quality audio is essential. These functions make optocouplers versatile components in electronics, particularly in situations where electrical isolation is crucial for the proper operation and safety of a system.